Hi guys, we're about ready to learn another technique of factoring. We factored out a greatest common factor. Then we learned a new technique called factoring out a difference of two squares. And then we did some factoring that involved a mixture of the two methods. We talked about that in the video called Factoring Completely. However, we're about ready to learn a little bit about factoring that is for a three-termed polynomial when there's not necessarily a greatest common factor. So this is probably the most complicated form. There's more than one way to do it. You've probably heard some people mention the AC method, but I think I'm going to go with the trial and error method for factoring trinomials. Remember, a trinomial is a three-termed polynomial. So, kind of strangely enough, we're going to start by doing a multiplication problem. If you remember right, that factoring and multiplying are like the opposite processes of each other. One undoes the other. So, looking for patterns when we do multiplication can help us become a good factorer. So I'm going to just put a random problem, a multiplication problem up here. Let's do 3x plus 4 times 5x plus 6. So, we're going to go ahead and multiply this out. Remember, using FOIL. So this 3x is going to get multiplied by both of these. There's your first, these are your outers, and now the 4 gets its term with both terms. There's your inners and your lasts. So 3x times 5x is 15x squared. The 3x times a 6, 18x. So I often put my finger here, just remind myself I've got to do both of those. Now it's the 4's turn, plus 20x plus 24. And then normally we get 4 terms at this stage, and then we add our two like terms that are in the middle. And 20 and 18 is 38. And this is the polynomial that we got. This is a trinomial. When we just went from this to this, we were multiplying. When we take something that's given to us that looks like this and try to reverse the process to get to something that looks kind of like that, that's called factoring. So multiplying takes a product and writes it as a bunch of terms added or subtracted. Factoring takes something that's written as a bunch of terms and tries to reverse it back to multiplication. Some things I want to point out. I'll even change colors for you. Notice this term right here, the squared term, came from multiplying the first term in this and the first term in that. Now, how does that help me when we get to the factoring stage? Well, I know that the things that go here and here have to multiply to this. So if somebody had given me something that looked like this, I know this can't be, for instance, a 7x and an 8x. Because when you multiply those, you get a 56x squared. But I want a 15x squared. So I have to make sure whatever I put here and here multiplies to give me the first term, the term that has that highest power. Notice also that this last term came from the number times the number. So I would know that the numbers I end up putting there would have to multiply to 24. So I would never consider putting a 7 and a 10 here, which gives me 70. So I make sure to restrict myself to numbers that when they multiply give me this last term. So notice this first term comes from that times that. This last term comes from the lasts multiplied together. The term that's hardest is the middle term, because the middle term came from adding these two terms together. And where did these terms come from? Well, the 18x came from multiplying what we call the outers, the two faraway terms, this term and that term. That's where the 18x came from. The 20x came from multiplying the two inners, or two close together terms. That's where the 20x came from. And we know that this term resulted by adding these two together. So when I test different possibilities, that's what trial and error means, is to kind of educated guess and then adjust your possibilities. We're going to be trying to get the two outer terms added to the two inner terms to be something that adds to this middle term. And I have a little bit of a way to do it, different from how some people do it. I kind of delay putting in signs, and I'll tell you what I mean by that when we actually try a problem. Okay, so if you want to take a quick picture of this, you're welcome to do a screenshot, but hopefully you are understanding when we do multiplication where these terms come from. Okay, I'm going to erase this now. Yeah, I graduated to an eraser from the microfiber that I've been using. Okay, so let's take a look at something like 3x squared plus 7x plus 2. Okay, so this is something that somebody already had two sets of print. They already multiplied it out. They already FOILed it out, and this is what they got as a result. And we're going to try to work backwards to see what they must have started with. I'll go ahead and put two parentheses. I know they multiplied two terms by two terms to get this. So I'm going to put up these two parenthesis sets, and I'm going to put them big enough to hold two terms in each. Now, do you remember that the first have to multiply to give you the 3x squared? Well, there's not many ways to get 3 with multiplication. 1 times 3. I don't think there are any more factors of 3. Since that's the case, I know there has to be a 3x and a 1x in these two locations. Now, I threw the x in there because I knew I also needed an x squared. So do you agree 3x times 1x gave me this? So I'm testing these things out. If this were a number that had more possibilities, like 6, it could be 2 times 3 or 1 times 6, then I'd be making a list of the possibilities and trying them until I found a combination that worked. So it's best to do factoring in pencil and to have a calculator handy if you're not too good with your times tables. Let's come over here. We know that the number term times the number term has to give us the number term. So how many possibilities are there? One number times another number that gives you 2. I believe 2 times 1 is the only pair of numbers that multiply to give you that. Now, this is where you'll often hear people decide how the signs should go. I delay that part, but that doesn't mean the person who has you make decisions about the signs in the beginning is wrong. We just have a slightly different way of approaching it. What I do is I put, without signs, these two numbers like this. I'm trying the 2 here, and I'm trying the 1 there. That may or may not work out. I'm about ready to check. I know that this times this has to come out to this. It does. I know that this times this has to come out to this. It does. So really the term that's in question is, are these things going to work out for that middle term? Do you remember that the middle term came from adding two terms together? The product of the outers added to the product of the inners. So I go 1 times 3x, 2 times 1x, and since I delayed putting the signs in for now, I just ask myself, if I had my way about signs, positives or negatives, could I ever get that to add to a 7x? Well, if they were both positive, I'd have a 5x. If they were both negative, I'd have a negative 5x. If I had one of each, I'd either have 1x or negative 1x. So there's no way we're going to get a 7x out of this. Do you see how the inners made the 2 get multiplied by this, and the outers made this get multiplied by the 1? Let's try reversing the 2 and the 1. Because you see, if I put the 1 here and the 2 there, it's going to change what these outers and inners give me. The product of the 2 outers is 6x. The product of the 2 inners is 1x. And if I have my way about the signs, how can I add these two and get a positive 7x? What signs would these need to have? I think they need to have both plus signs. Do you agree that that adds to 7x? Well, that's handy. Now, where did the 6x come from? From this times this. So I'll put a plus sign here so that that comes out to a positive 6x. And I'll put a plus sign here so that that comes out to a positive 1x. Using my method of delaying the signs, I have to always make sure to double check that I already knew I got a 2 of some form out of this. I already checked the 2 times 1, but now let's check the signs. Positive 2 times a positive 1 does give me the proper sign there. If it didn't, then it just means I stumbled on a combination that was close, but actually isn't going to work. So this multiplies perfectly to be this. So this is my final answer. It is this thing factored. Notice I made a very short list of the numbers that multiply to give me 3. Notice I made a very short list of the numbers that multiply to give me 2. If you want, you can certainly take a snapshot at any point you want. We're going to try another one. Okay. And here's another one for us to do. How about let's go with 2x squared minus 9x plus 9. Let me make sure that was the one I was talking about. Yes, it is. All right, so let's try this problem and see if we can figure out, what I must have just started with that I multiplied out that came out to be this. So this is the result somebody got from multiplication. We're going to try to work backwards to figure out what they had before they multiplied. Okay, I remember that the first times the first has to multiply to this term right here. We know there's an x in each place because that's where the x squared will always come from. But as far as possible numbers that multiply to be a 2, again, there's only one combination. By the way, 2 times 1, 1 times 2, it doesn't matter which way I write those. Okay, so I'll just, since there's only one possibility, I'll just pencil them in. And again, I don't have to write the 1. It's something that you can do if you feel like it's easier for you, but for now, I'm just going to leave it there. We know that this number term times this number term has to give me a 9. And here's where there's now more than one possibility. So 9 can come from 1 times 9, or it can come from 3 times 3. Okay, I don't know which one of those is going to work. This is why you use a pencil. Okay, so I'm going to try, usually, the two numbers that are closer together to each other are ones that I try before I try the 1 and the 9. But I'm going to try, just so that we have a little practice with seeing what things give us, I'm going to go ahead and put the 1 and the 9 here. I know that those multiply to give me the right number, but it's this middle term that I have to make sure works. So remember that this middle term comes from multiplying the outside terms, 18x, and multiplying the inside terms, 1 times 1. X is just this. So if I were going to combine these two terms, and if I got a chance to make them positive or negative, however I wanted, could I ever add these two, no matter which of the signs I had chosen, to get a negative 9? 18x and 1x is 19x. If you subtract them, you get 17x, if I make one of them negative. So it's not going to work to get us the proper middle term. Before I get rid of the whole possibility of 1 and 9, I try 9 and 1, just to see if that works better. Again, I'm restricting myself to the numbers that I know give me the proper first and last terms. So I'm just really checking the middle term every time. 2x times 1x is 2x, and 1x times 9 is 9x. If I have my way about the signs, can I ever add or subtract these to get a negative 9x? If they were both positive, I'd get an 11x. That's not the same. If one of them was negative, I'd probably get a 7x or a negative 7x. That's not the same. It doesn't look like these two numbers, whether they're 1 and 9 or 9 and 1, are going to work for us. So I kind of put a little check mark over here that tells me I've already tried both of those numbers in both positions. The last thing I want to do is overlook the right choice, so I go slow and steady with this. Let's try the 3 and the 3. One thing that's nice about trying the 3 and the 3 is, since they're the same, we're not going to have to turn the numbers around to check them in both positions, because they'll give us the same thing, both being the same number. Let's check the outers. 2x times 3 is a 6x. Check the inners. 3 times 1x is 3x. If I have my way about the signs I attach to this, can I ever add or subtract these to get a negative 9x? I think I found my possibility. I want them both to be negative so that when we add them, you get a negative 9x. So negative 6 and negative 3 gives me negative 9. So I come back over here, and I know the 6x came from this times this, so I'll go make this number negative, and the 3x being negative, I'll go make the 3 negative. The last thing I always have to check, if I'm going to delay putting in my signs from the beginning, just double check, does this times this give me the right sign? Negative times a negative is a positive. By golly, we found our culprit here. We found our answer. The person must have started with this in order to get this. We factored another one. Okay. Take a screenshot of that if you'd like. I'm about ready to erase it for us to try another one. If this way doesn't work after practice, it takes practice. And after you get going and you get used to this, you get better at guessing which things to try first. There is another technique called the AC method out there. It has 4 or 5 steps, and it works every time, but the 4 or 5 steps are kind of hard to remember sometimes. So I'm thinking, at least by using this method, you're understanding that multiplication and factoring are reverse processes. Okay, let's try another one. Let's try. See, I've got my cheat sheet because I actually already multiplied some things out. Let's try. Well, I don't like any of these. I'm going to try a different one. Okay, I'm going to try This one's going to be hard. So 6x squared, and then plus 23x plus 20. You remember all that multiplying out we did in our head? I just had to do that right now. So I'm hoping that I did it correctly. So this one is more complicated because now there's multiple possibilities for this number and for this number. So we might have to try things a little longer. And we have to be careful to do very systematically, make sure we check all the possibilities as we go along. So again, I know somebody multiplied a two-term thing by a two-term thing, so I set up two sets of parentheses, each designed to hold two terms. Now I know that this times this has to equal this, but 6 times 1 is one possibility to get a 6. What else can we use? 2 times 3. So at first I don't know which pair to try. To get the 20, it could be a 1 times a 20. It could be a 2 times a 10. 3 doesn't go evenly into 20. 4 does. 5 times 4. That I already have listed. Now once I start having repetitious pairs, that's the whole length of my list. I don't have to look further. So once I see 4 times 5 and then 5 goes in evenly and it's 5 times 4 and that repeats a pair I already know, we can be done. Okay, so let's go ahead and try. And just to make your life easier, if this is a pretty tame equation, polynomial, if it's 6x squared plus 439x plus 2, then I suspect it's something weird, and perhaps it's these far away numbers that cause that. So I usually start with the number pairs that are closer together. So I'm likely to try a 3x and a 2x in these positions first before I go with that. That won't always pay off. Sometimes it'll end up being this pair. But I'm going to try this pair with all of those pairs, both turned this way and reversed. And if none of them work, then I'll go try the 6 and the 1 with all of those. Hopefully I don't have to do all those different possibilities. So likewise over here, I usually take the closer together numbers before I try the wider spread numbers. So I would try the 4 and the 5 before I would try the 2 and the 10. Sometimes, though, that doesn't work. So I'm going to go ahead and put the 5 here and the 4 here. I could have tried it 5-4 or 4-5. It doesn't matter, because I'm going to have to try to check all the possibilities. I already know that this times this gives me this, because I restricted myself to numbers here that would give me the 6. And I've already tried this times this, and I made sure that I've only listed things here that would give me a 20. So I don't have to keep on checking those all the time. It's this middle term that I'm wondering if that will work out. So remember, this middle term comes from multiplying the outers and multiplying the inners and adding them together. So the outers give me a 12x. The inners give me 5 times 2x is 10x. If I have my way about signs, and this is where your calculator can be handy, if I can make these any signs I want, will that give me a positive 23x? Well, if I added a 12 and a 10, that's 22x. This is where your calculator can be helpful, which is not a 23x, even though it's close. If one of them was negative and one was positive, it would either give us a 2x or a negative 2x. and that's not a 23x. So putting the 5 here and the 4 there didn't work. But remember, when these things are different from one another, you've got to try it in the other position. So I'll put the 4 here and the 5 here, and let's try that. My outers multiply to give me 15x. My inners multiply to give me 8x. So you take your calculator and you add 15 and 8, and you get 23. 23x. If you can get a positive 23x, if both of these are positive. So what I do is I come up here, here's where the 8x came from, I'll make it positive, so I get a positive 8x. And the 15x came from these, so let's make the 5 be positive, and that'll ensure we get a positive 15x. Are we done? Almost. Remember, the last thing you've got to check is I already knew that 4 times 5 gave me 20. That's how 4 and 5 ended up on that list. But I have to make sure the sign works out. Positive 4 times positive 5 does give me a positive 20. Wow, we just found the factors pretty quickly. Now here's a secret. When you're factoring, most of these will not be as complicated as this one. So most of the ones you do will be even easier to find because you won't have as many possibilities to check out. So we have just factored this trinomial, and it seems to have worked out, and we found the factors. So this times this gives us this thing right here. This is the factored form. It's written as a multiplication problem. I hope that this has been helpful, and good luck with doing the trial and error method. Don't be afraid to try a combination that doesn't work right away. Just try 6 and 1 or try 2 and 3, but try them with all the combinations. So good luck, and you have a nice day.